Okay, question 3c. There are two methods you could use for this one. You could use the Hess cycle and you can use the delta H equals the sum of HF of products minus reactants. So I'll do the Hess cycle first and I'll show you the other method. So if it's formation, you know it's forming from its elements in their standard state. So we've got nitrogen, that's going to be N2 as a gas. We've got oxygen, so that's going to be O2 as a gas. We've got carbon, which is going to be a solid. So we know they're going from here up to there. And I'm going to put through, that's the direction they're going from their elements to the products. So let's put some numbers in that we know from the table we're given. So the formation energy for this one is minus 365. I've only got 1 mole of it. For the carbon, it's going to be 0. Would times it by half, that's going to make no difference. For the nitrogen, again, that's going to be 0. For the water, because we've got 2 there, it's going to be 2 times minus 242. Which equals minus 484, and then we've got to have half, because of that number, times minus 394. Now if we tally these up for each direction, we're going to get a total of, if we call this delta H1 equals minus 365, and on this side, if we call this delta H2, that's going to be minus 681 kilojoules per mole if we add those up. I'm just going to circle those. Now, if we call this delta H3, and that's what we're trying to work out, if I look at this and look at the arrows, this route, the arrows are going in the same direction, will equal this route here. So I can say confidently that delta H1 plus delta H3 will equal delta H2. So if I input the numbers I have, I've got minus 365 plus delta H3 equals minus 681. So I'm going to rearrange to make delta H3 the product. The focus, now I could have done this earlier, but I find that a lot of people get muddled with a negative sign. So if you put it in like this, you're less likely to make a mistake. But obviously I trust your math skills to make a collective decision. So I'm going to plus 365 to each side, so I get delta H3 equals minus 681 plus 365, and that gives me the number minus 316 kilojoules per mole. And that's the correct answer. Now we could have used, just move up a little bit, the equation delta H equals the sum of the enthalpies of formation for the products minus delta, sum of the delta HF formation of the reactants, and you're basically doing the same sum. I think quite a lot of people in the recent test got these the wrong way round. We're confusing those with bond enthalpy, bond making, bond breaking equation, so we've got those the wrong way round. So the numbers we should have, it equals 2 times minus 242 plus half times minus 364, and you can put extra brackets in if that helps, minus minus 365, so obviously that turns to a plus, which is what we had up here, and that gives you minus 316 kilojoules per mole. And that are two different methods for calculating the answer to question 3c.